All right, ladies and gentlemen, we are still in chapter 2. So you are going to want to have your notes out to take notes. We are learning today about absolute value. Not only will we be evaluating absolute value, but we will also be solving absolute value equations, which can be a little tricky. So recall that absolute value is the distance from 0. So if you look at the absolute value of 4 versus the absolute value of -4, well, here is 0. Here is 4. And here is -4. So the absolute value of -4 is -4's distance from 0. In other words, 4. The absolute value of 4 is 4's distance from 0. In other words, 4. So the reason why the absolute value of 4 equals 4, as well as the absolute value of -4, is because they are both equidistant from 0. So absolute value is how far you are away from 0. And essentially it is the value of the number without the sign, the absolute value. So if we're evaluating, we are taking the absolute value of 3 times -2 minus 1. What you're going to do is evaluate the entire inside of this expression, and then you can take the absolute value. So you'll do orders of operations here. So the absolute value of 3 times -2 is -6, and then minus 1. -6 minus 1 is -7, and the absolute value of -7 is 7. So you bring this down so it's just a number, and once you get it to just a numeric quantity, you can take the absolute value. And the absolute value of -7 is 7 because -7's distance from 0 is 7. Okay? That's how you evaluate expressions with absolute value. And we did talk about this when we did our unit on Please Excuse My Dear Aunt Sally, which was our orders of operations unit. So now if you're going to evaluate this, notice the negative is on the outside. So that's negative absolute value of -10. So first we do what's in the absolute value first because it serves like a parenthesis. So the absolute value of -10 is 10. And then we bring down this negative sign. So the answer is -10. So you would think, oh, the negatives cancel. They do not cancel because the absolute value of -10 is +10, and then that negative sign comes along for the ride. Now, solving is a whole nother ball of wax because you have to consider, what can I plug in here, take the absolute value of, and get 5. Keep in mind when you're solving absolute value equations that you almost always, most times, usually, let's say, you get 2 solutions. Why? Because 2 numbers have a distance from 0 of 5. All right? So since 2 numbers have a distance from 0 of 5, you'll get 2 answers. So the way you solve these is you say, well, the inside of here could be 5, and that would be true because the absolute value of 5 is 5. The inside of here could be -5. So this is the positive and the negative possibilities because the absolute value of 5 is 5 and the absolute value of -5 is also 5. So you have to consider both possibilities because inside here could be 5 or -5. So we get two answers, x equals 5 and x equals -5. So usually you get two solutions. So that is a big key concept here with this particular solving section. Sorry, I went a little nuts there. Usually you get two solutions. Now, at this point, notice that you have x plus 3 equals 15. This is very important. This is something my Algebra 2 students forget a lot of times. You want to isolate your absolute value expression. So you want to get this by itself. So I'm going to subtract 3 on both sides. So I get the absolute value of x equals 12. And then, in order to clear the absolute value sign, or in other words, in order to free x from the absolute value, you have to consider the positive possibility and the negative possibility. In other words, both sides of 0. So x could equal 12, or x could equal -12. Because if I plug in 12 here, the absolute value of 12 is 12. The absolute value of -12 is 12. Two different answers. But you don't want to split until you have isolated your absolute value expression. Very important. Excuse me. When I take a look at this, I have isolated my absolute value expression. There's nothing on the outside of that expression. So what I can do is split into my positive and negative possibilities. So x minus 4 could equal +6, or x minus 4 could equal -6, right? Because inside here could be 6, because the absolute value of 6 is 6, or inside here could be -6. So we consider both possibilities. So I'm going to solve. Add 4 to both sides. Same thing over here. So I get two answers, x equals 10 and x equals -2. And if I wanted to check my work, let's check x equals 10. If I checked x equals 10, I'd have the absolute value of 10 minus 4. Does that equal 6? Does the absolute value of 6 equal 6? Well, yes it does. Check. That works. Now check x equals -2. Does the absolute value of x minus, let's plug it in. Whoa. X equals -2. Let's check that. So does the absolute value of -2 minus 4 equal 6? Does the absolute value of -6 subtracting equal 6? Well, it does, because 6 equals 6. So you can see that both of these values work because the absolute value of 6 is 6 and the absolute value of -6 is 6. So they both work. Two different answers to one equation. Again, you're going to want to isolate your absolute value sign. You don't want to split it up yet. That is going to be a bad news because you're going to end up getting something that is just not correct. Only one of the answers will be correct if you do it that way. So you're going to want to isolate your absolute value by adding 2 to both sides. Now we can split it because we have isolated our absolute value expression, and we'll consider our plus and minus. So once we split it, we don't need the absolute value signs anymore because we have accounted for the fact that it's an absolute value. So we get x plus 5 equals positive 10 for our positive side, and x plus 5 equals negative 10 for the negative side. I'll subtract 5 on both sides, and I get x equals 5. Subtract 5 on both sides, and x is going to equal negative 15. And those are my 2 answers. But again, do not fail to get the absolute value expression, this business, right here, all by itself. Again, we're going to want to get the absolute value all by itself. So I'm going to add 2 to both sides. Whoa, that was a curvy line. That is not much better. Let's do a real straight line. It's a little better. So I add 2 to both sides, and I get 3 times okay, then I divide by 3, because again, I want to isolate my absolute value. Now I've isolated my absolute value. I can then split up into plus minus. So x plus 4 equals positive 5, and x plus 4 equals negative 5. Because the interior of that absolute value could be positive 5 or negative 5. Subtract 4 on both sides, and x is going to be 1, or x is going to be negative 9. And you could substitute those values in. Let's just try 1. 3 times 5, 15, minus 2 is 13. And we could sub in negative 9, and that would work as well. Let's try this one. Subtract 2 on both sides, again, to isolate our absolute value sign. Divide by 3. All right. Now you might think, oh, I'm going to split it up into 2 problems. Well, this is where I need you to have some bells go off in your head. This is where we need to say, no. Sorry, went a little creative there. Absolute values cannot be negative. Absolute values cannot be negative. So notice what this looks like. You have an absolute value equaling a negative. If you have an absolute value equaling a negative, there is going to be no solution. And if there is no solution, you don't have to do any solving at all. You are simply done. That's it, no solution. So when you get that the absolute value equals a negative, you have to stop, hear some bells and whistles going on in your head, and know that there is no solution because absolute values cannot be negative. The reason that is true is that you cannot have a distance be negative. Absolute value is defined as the distance from zero, and distances are not negative. So there is no solution, or, yep, so you just write no solution. Your homework today, which you can start here in class if there is time, is a worksheet, 1 through 27 all. Please get started if you have time.